Hello, it's the differential calculus using the general formula. Before we move into differential calculus properly, I want to explain some terms under the concept. And they are, given that y equals ax raised to the power n, where a and n are real numbers. Real numbers are your everyday number, regular numbers, be it the integers, the fractions, or the decimal numbers. And that x and y in this concept are variables. Then a is called the coefficient. The coefficient is a number beside a letter. So a is the coefficient in this concept. N is the power of x, as we can see. N represents the indexes, so that's the power of x. And x is the independent variable, while y is the dependent variable. Now moving on to the derivative aspect. It says that if y equals ax raised to the power n, then dy by dx equals anx raised to the power n minus 1. What happens there is that the power of x, which is n, comes behind when you want to do dy by dx. It comes behind to come and multiply a. That's why we have a multiplied by n gives us what? An. Now, when we multiply it by a, what we do is that we subtract 1 from that power. So that is an x raised to the power n minus 1. That is what we see there. Now, we have these following examples with which we are going to explain that concept better. And the example says, find the derivative of each of the following. Now, I was careful in selecting these questions of the example, because I wanted to cater for different aspects of this differentiation or derivative, as you may want to call it. So this example A, B, C, D, and E. You'll be seeing different concepts under each and every one of them. So let's go with A first. So A says that y equals x raised to the power 5. So in finding the derivative, is the same thing as finding what the differentiation, or you differentiate y with respect to x. So that tells us dy by dx will be equals to, this 5 comes behind to come and multiply the coefficient of x as we have it in the general formula there. That becomes 5 multiplying x. And what happens to the power? We are going to subtract 1 from the power. That's going to be 5 minus 1, just as we have it there. So this becomes 5, the coefficient of x is 1, so 5 times 1 is going to be 5. And then that's going to be x raised to the power 4. Very simple and straight. Right. Now onto the B part. We have y equals x raised to the power half from the question. So we're looking for dy by dx. So dy by dx, as before, becomes the power 1 over 2 comes to multiply x raised to the power 1 over 2, then we subtract 1 from the index. So this becomes 1 over 2 multiplied by x raised to the power 1 over 2 minus 1 is going to give us negative 1 over 2. And according to one of the laws of indices, we need to deal with this negative power. So by the law, it gives us 1 over 2 multiplying 1 over x raised to the power 1 over 2 by that law. So the negative sign has been dealt with. So what does this become? That becomes 1 over 2x raised to the power 1 over 2. That's one way to represent the solution. Or if you decide to simplify further or evaluate further, that becomes 1 over 2 root x. That's according to law of indices also. So either of these two is acceptable for the derivative. Thank you. C, y equals 1 over x raised to the power 4. So we are going to do a reversal of what we used in B before now. So y equals 1 over x raised to the power 4 is the same thing as y equals x raised to the power negative 4. Right? So we have to bring it to this format so that we can apply the general formula successfully. So when we have y equals x raised to the power minus 4, so what's going to be dy by dx? So dy by dx is going to be equals to negative 4, which is the power, comes to multiply x raised to the power negative 4, and then we subtract what? 1. Remember, the power from the index, we need to remove 1, just as we have it there. So that becomes minus 4 x raised to the power minus 5 for dy by dx. So your solution can be left like this, or bring it to this format. This format again. So that becomes minus 4 multiplying 1 over x raised to the power 5 in order to deal with the negative sign. So there becomes minus 4 over x raised to power 5. So either of these two solutions is acceptable. D, y equals negative 4 over 3 x raised to power 6. Alright, so the y by the x becomes what? 6 comes behind. So come and multiply negative 4 over 3 and then x raised to power 6 minus 1 as before. So that becomes 6 multiplied by negative 4 over 3. 3 here 1, 3 here 2. 2 times negative 4 is giving us negative 8 x raised to power 5. So that's our divide by the x. Very simple and straightforward. Letter E, which is the final example in this section. So y equals cube root of x squared. So we are going to rewrite y. So y is going to be x raised to power 2 over 3 by a law of indices, the fractional power law actually. So what happens here? The y by the x becomes 2 over 3 coming behind, so multiply x raised to power 2 over 3 minus 1. And so that becomes 2 over 3 multiplying x raised to power negative 1 over 3. When you do 2 over 3 minus 1, it's going to give you negative 1 over 3. And then simplifying this also by that law of indices says 2 over 3 multiplied by 1 over x raised to power 1 over 3. This helps you to deal with the negative power. So what happens in this case? So that becomes 2 over 3 x raised to power 1 over 3. That's the derivative, 1 over 3. So this is a way to represent that. Another way to represent it is this, or 2 over 3 with cube root of x, because x is being raised to power 1 over 3. So this 3 comes here, and then the 1 is assumed to go up. But because it's ordinary 1, it doesn't have any effect. So either of these two is acceptable for the derivative of this function. So that brings us to the end of the differential calculus using the general formula. Until we move on to other aspects of differentiation or the differential calculus,